Okay, so this is day 2 for 7th grade math, chapter 6, section 2, where we're graphing linear equations, right? So today we're going to see a couple of special cases. And this is what they look like. So we're going to draw a coordinate plane for each and see if we can graph these special cases. This section is about graphing linear equations. So you are being asked to graph a linear equation that says this, x equals 3. That seems really different than the others that we've graphed, doesn't it?
Mm-hmm. Yeah.
Usually when we're dealing with a linear equation, you're used to seeing how many variables? 2. And the variables you're used to seeing are?
X and Y.
X and Y both. And look at this equation. X equals 3. It's very strange.
Why?
Okay, and that's why it's called a special case. Doesn't it look simple?
Yeah.
Sometimes things that look simple can be so tricky. It just messes us up. So we have to carefully graph something that looks simple, but we can't find, it doesn't seem like we can find ordered pairs for this, does it?
No.
Same with this equation here, y equals -1. So tell me, if you have this kind of an equation, what could you do? I mean, if we start here at 0, 0, starting right here at 0, 0, the center, where is x equaling 3? Would I go, and you're going to just choose one of these words. Where does x equal 3? Would I go up, left, down, or right? And the answer is?
Right.
Who says up?
I did.
We have 2 people. Who says right? We have about, ooh, look at that. It's right down the center of the class. We have about, what, 11 people saying right? And that's true. If we travel from this 0, 0, and we travel right 1, 2, 3, we have x is 3 there, don't we? Where else is x 3?
Down.
Oh, Amanda, was that you? What'd you say?
Down.
Down. So if we go down to, let's make a little table here. When we have x and we have y. This point that we found right here has a value of 3 for the x when y was 0. We didn't fly at all. Now Jimena says that there's another x is 3 down here. So when x is 3 there, y is -1. See that? And we could also move up from that first point, couldn't we? We could find another place where x is 3 just above it, right? So when x is 3, in that case, y is 1. So which value in this table, here is not changing? Which value is not changing, Sophia? 3. The 3, and that's the x, isn't it? The x's are not changing. I've got to move this out of our way, so I'll do that. I might have to move it in pieces. There we go. And our little table looks really strange because all of the x's are 3. But that's what this statement is saying. All of the x's are 3. It doesn't matter what the y is, all of the x's are 3. So could we connect these points we found? Could we do it?
Yes.
Yes. And when we do, this is what we have. No, that's not good. Try to use your card. Stay right on those points, right? This is what we have.
I don't think you.
Isn't that interesting? What?
Did you give us cards?
Yes, I did. I gave both classes note cards to use as a straight edge. So use those straight edges. So what type of a line is this? Those of you who are skateboarders who go down to the Y, you know what this is called. This is a, say it, Bella, vertical, right? It's a vertical line. So when you are on the top of that skateboard park thing, how high is it?
I think it's, the one at the Y, I think it's like 15 feet.
And they call it the vert ramp because it's a place to drop down, right? Good. Wouldn't a horizontal ramp be boring?
Yes.
I'm really good at the horizontal ramp. Okay. So here we have a vertical line, okay? So 7th grade.
I don't see my hands.
Quiet, please. Vertical lines. Vertical lines. Do you see the little definition here? Vertical lines are the case where we have x equaling some constant number, some non-changing number. like this example had x equals 3. We could change x to any number. When we do, we would go draw a vertical line at that x. What makes this tricky is which axis is vertical? Which axis is vertical? The y. So when somebody graphs this, x equals 3, sometimes they make the mistake to draw it horizontal. Do you understand why they would do that?
Yes.
Because if they did, the x-axis is horizontal. So you have to always start at 0, 0 and go to where x equals 3. So you're going to the right where x equals 3. And you'll get the perfect line if you do that. Okay?
What does that say?
Okay, so based on our first graph here, can you by yourself now go graph y equals -1? Pause the video, pause your life here, and go do that. Okay, so we again start at the point of origin, 0, 0. And you're going to tell me left, right, up, or down. Which direction do we travel to get to y is -1? And it is?
Down.
Down 1, right? And where else is y -1? Somebody tell me, where else is y -1? Okay,
To the left.
to the left, right here. Y is -1, right?
then you put
And now you draw your line. Which should be right through those points. Okay? My board is not cooperating. It should be right through those points. Okay, so this is an improved line here. It should go right through y is -1. And no matter where you go on this new line here, all of the y's are -1. So Sophia's asking, what does that look like in a table? Okay, so in a table where we have x, y, all of the y's are at -1. This is opposite the last graph, isn't it? This is opposite. So no matter, in our first point that we found here, when x is 0, y was -1, right? We could go to the left, like Casey said. X is now -1, but y remains -1. We could keep going to the left. Let's go to this point over here. When x is -2, y is still -1. So the tables look strange too, because these, again, are special cases. No matter where you go on the graph, all of the y's are -1. So these always give you horizontal lines. So the rule, again, for a horizontal line is down here. Horizontal lines are y equals some constant. That is represented by B in this case. Horizontal lines are y equals a constant. Constant means a non-changing number, okay? Okay, so here we have a coordinate plane. Let's try this again. This is a little test for you. How do you do this? So I'm going to use the GP on page 322. 322. It's the guided practice. And there is no talking. The first question on that page says y equals -4. So go and attempt to graph it. When you graph, label your x and y axes. Label one number in each direction so that I can tell your scale. Okay, the equation that we have been given is strange. It is just y equals -4. So Sophia, if I start at the point of origin right there, right? How do I get to y equals -4?
You have to go to the have to go up and down.
How many down?
4.
1, 2, 3, 4. Okay, so here is y equals -4. Where else does y equal -4? Well, let's make a table. You just gave me this. You gave me when x is 0, y is -4. And I said when you're making a table for this, you could just write -4 everywhere in the y place, because that's what this equation says, right? But give me another x. Give me some other x. Okay, so if we put in 1, can we find that place? How do we find that place? 1, -4.
You
Walk 1 and fly -4. There you go. Now we have 2 points that are starting to line up, right? You could go the other way. How about if we walk -1, we would fly -4, right? So do we have 3 points lining up now? And we simply draw the line to show we could go on forever choosing x values, but y is not changing. Okay? Okay, you may graph this second one on the same graph. This is number 7. We're going to graph, this time, x equals 3/2. I'm going to do it over here. X equals 3/2. Okay? It's a good one to do because it's got fractions, and so everyone could freak out over fractions, right?
Yeah.
3/2. Oh my goodness, how do we handle that? So, we can make a table. If you don't like this number 3/2, you can change it, can't you? How about if we change it to a decimal? You like decimals? So 3/2 as a decimal. 3, 2, 1.
1.5.
1.5. So we could call x equals 1.5. We could say that. So all of the x's are 1.5. So somebody give me a y. Any y at all. Tatum. She says 1. Another y I just heard was?
0.
0. And then what else do you think we might try? -1. Good. We'd like to have a negative, a positive, and a neutral. Okay, so we're going to graph these ordered pairs. Walk before you fly. Which way will we travel for this first point here? Walk before you fly. Which way do we travel?
To the right.
To the right, 1.5, and
And half. Like
down
between.
1. It should be right here. It's between the 2 corners, right?
0.
Point 2, walk 1.5 and fly 0. There it is. Point 3, walk 1.5 and fly 1. There it is. And what? It should be very straight with your straight edge. This is a very bad one. I'm going to redo it. Let me grab a line, and it should be very straight. And there you go. X equals 1.5, and it's not even parallel to the x-axis. It's parallel to the y. It's the opposite what you think, huh? That's what makes these tricky. Okay? Okay, so here's your assignment. Again, very careful graphing. Use your graph paper. Make your table. You're doing awesome. It was the best first graphing day I've ever had with you yesterday, so keep up the good work today. Okay?